say are the key takeaways for the IBL solutions?
The IBL machines, the development of those machines has already been since 35 years. So we've been working on many features and have loads of experience generally in the vapor phase technology. The machines are very environmental friendly, energy saving if you look at the costs, and we all manufacture everything in-house. So also we are not so much influenced by delivery of materials and so on. But in generally you can solder any kind of application with a high density of components on the board, high voluminous products or components, more voluminous simultaneously on a board. Any kind of profile can be set up very easily and very fast. In vapor vacuum, meaning that we don't remove the assembly out of the process chamber into a vacuum chamber, because the vacuum chamber is in the vapor. So that means that we don't have any temperature loss on the assembly, because the vacuum chamber is in the same temperature as the whole unit. So that's a large advantage in the cycle time of the vacuum process as well, and in end effect the quality.
And this is patented to IBL?
Yes. Including of course our standard transport system, non-vibration and maintenance-free transport system. And we've got more than 50 patents.
Wow.
It's impressive.
Excellent.
Let me just run a cycle, then you will see.
Thank you.
That's where you load the product. We have different handling systems or trays. Depending on the size of the board, you can adjust the width for the specific product.
We have
and then when you load the product and also have set up the profile, setting up the profile can be very easily done through connecting thermocouples, and we have a direct interface to the display, so you don't need any additional external software. You can connect up to 4 channels. And on a machine with a vacuum chamber, we have a solder star profiler, which also communicates with our main display. So when you place your products on the tray, you press the start button. The assemblies move into the first chamber, where it can. Then finally, the assembly is transported into the process chamber, where it begins to heat up. It's important, you can see the flap which is opening and closing, so we are also intensively looking at the consumption of the fluid, because obviously the fluid is something which is a consumable product, and we are trying to consume as less fluid as possible, of course. So you can see now the transport system is moving down, and another patent that we have is the so-called soft vapor phase, meaning that within the vapor blanket we can move to different positions, because obviously a large voluminous component will take more time to heat up compared to a small SMT component. And the heat transfer is obviously much quicker the lower you are in the vapor blanket. So the way we handle it is that we can move to 20 different positions within the vapor blanket to reach the same temperature of all of the components before we actually move down. Now you could see the vacuum chamber closing, that will evacuate, and of course here we are running the machine without heating it up. So you see no vapor, but basically the whole handling can be presented here. So now the cooling process starts, you can see the fans running. The flap opens up. course, this is a demo cycle, so normally it will take about 8-9 minutes for the whole process, but you can place basically several components onto the tray. So we don't solder just one product simultaneously, but multiple products.
Thanks, Olaf.